Right, then. Okay, let's start. Good morning or good evening, everyone. It is yet another day that we are here together to discuss a past paper. And we're doing 0606 for obviously additional mathematics. It is paper 1, variant 3, and we're doing the October-November 2018 series. Next. Okay. I will be doing number 6 of this past paper, so please get out the past papers. You can search it online through my following October-November to 2018 0606 13, paper number 13, and I will be discussing kinematics. It's our favorite subject.
Did you just say kinematics?
Well, I did say kinematics.
Oh, and you're going to teach them how to do kinematics.
But it's my maths project. I need to do work.
No.
Let me do my work.
You can't teach kinematics. Move over, let
Fine.
me do it.
Okay, I'm leaving. Well, scooch over. Let the real teacher teach you about kinematics. Dear God, a mere girl wants to teach you about kinematics. The preparation she's done. Well, I, Isaac Newton, the real teacher, will teach you about kinematics because I created the base for kinematics. Yes, I time traveled, grew my hair, aged backwards, lost my luscious curly hair, but that's that. Let's get to the real point of this meeting that we have. Well, let's go on and do the first question. A particle P is moving in a straight line such that its displacement Sm from a fixed point O at time ts is given by x equals 12e to the power of negative 0.5t plus 4t minus 12. Well, let's start with the basics. What do we know about kinematics? Well, the question asks us P is instantaneously at rest. What does that mean? An interesting choice of words, isn't it? Well, by instantaneously at rest, it means that V is equal to 0. Now, how did I deduce all of that? Instantaneously at rest means that it is not moving. It is instantaneously at rest. Yeah. Now, we only have S being displacement. How do we change displacement into velocity? Well, I'll give you an easy formula for you to remember. All you need to know is the basic laws of integration and differentiation in order to master kinematics. Integration of velocity to find displacement. I apologize for my horrible handwriting, knowing that I'm writing with a touchpad. Anyways, going further, acceleration to velocity, if there's integration here, that means there's integration here as well. So, I would say we change A dt equals to V. Okay, we have that. So we know that integration is going on here. Integration is going on here. And on this side, we're going to say that differentiation is going on. If integration is going on here, the quite opposite is going on the other side, isn't it? Oh, again, pardon me for my horrible handwriting. On the other hand, velocity to acceleration, dv over dt. Perhaps the question says that you only have your displacement. So how would you find acceleration? Well, the other way out is the double derivative of displacement to find it. So first things first, you know that S equals 12e to the power of negative 0.5t minus plus 4t minus 12. Now we use differentiation, as I mentioned before. Well, I have to explain that you need to know the basic laws of integration and differentiation. In this case, I use the natural number law, which is e to the power of ax. Now, ax plus b. So, in order to know, a always comes to the front and e to the power of ax plus b remains the same. So, it would be negative 6 e to the power of negative 0.5t plus 4. Obviously, you know that during differentiation, the t's index is always minused. So, once we know that, maths, you can move the negative 4 here, equals to negative 4, and then e to the power of negative 0.5t, e to the power of negative 0.5t is equal to negative 4 over 6. Now, moving further, after simplifying this, you must be wondering, how do we move the e and try to find negative 0.5t? Well, with simple logarithms laws, we'd be able to do so. So negative 0.5t is the index in this case. With this answer, we would have to remove the index, make it the subject. And
It appears that even the great Isaac Newton, who took over my math project, can even still make mistakes. As you can see, his working shows that e to the power of negative 0.5t is equal to negative 4 over 6. But actually, negative 4 and negative 6 being simplified and divided would be 4 over 6, and then simplified would be 2 over 3. So it should be e to the power of negative 0.5t is equal to 4 over 6. And then go on to using the logarithm rule. You change negative 0.5t is equal to ln 2 over 3, and then t is equal to negative 2 ln 2 over 3 because we divided by negative 0.5. Hence, you can get your answer by putting these numbers into the calculator.
therefore, we have a positive here. And our answer would be, if we put it in a calculator, we should be able to get 0.811. T is equal to 0.811. Find an expression for the acceleration of t at time t should be equivalent to the displacement double derivative. Make it simple. All you have to do is use your answer from the previous question. Okay, so after this, you need to do, using the laws that I've told you about, you have to do negative 0.5 times negative 6 would be equivalent to 3. 3 acceleration is equal to 3e to the power of negative 0.5t. Find the value of s when the acceleration of t is 0.3 meter per second square. 0.3 meter per second square. So previously we knew that acceleration is equivalent to 3e to the power of negative 0.5t. After much deriving from displacement to velocity to acceleration, we get 3e to the power of negative 0.5t. Now what do we know? This question is asking us about finding the value of s. What is s? S is our displacement. So we have to find our displacement using acceleration. But how? So quite simply we do 3e to the power of negative 0.5t is equal to 0.3. Moving on, we make e to the power, because we want to make 0.5t as a subject, is equivalent to 0.3 over 3, which would make it e equals to e negative 0.5t is equal to 0.1. Again, applying the laws of logarithm to this. We make t the subject, so t is equivalent to negative 2 ln 0.1. Known that t is equivalent to 4.60517, we use substitution. Make s, so we get our trusty displacement formula back of the equation, and we will substitute our newfound t into the answers. Moving on, this will be our answer. So basically, you will have to find t first, knowing that it is a common variable in the two equations. Then you have to use the answer that you were given here, 0.3 in the acceleration equation that we knew, and then you are able to find the answer to t. Once you find t, you use substitution to answer the following question. So let us look upon this. Explain why the acceleration of the particle will always be positive. Well, we know the acceleration was a equals 3 into negative 0.5t. Okay, a equals 3e to the power of negative 0.5t. Well, think about it. E to the power of negative 0.5t. Completely discard 3 because no matter what you do, 3 times negative 1 is always negative 3. 3 times negative 2 is always negative 6. So regardless, that 3 depends upon the e to the power of negative 0.5t. So what will be the answer of negative 0.5 e to the power of negative 0.5t that will make it positive? Well, we need to think about natural numbers and index law. Now, think about it. E to the power of, if you think about it, e to the power of negative 0.5 multiplied by 0. What happens? Well, e to the power of 0. Upon knowing the index law, you know e to the power of 0 is definitely equivalent to 1. Multiply that by 3, you get a positive 3. What about a negative number? Can e to the power of negative 0.5t be equivalent to a negative number? Well, if e to the power of negative 0.5t can't be equivalent to 0, do you think it can be equivalent to a negative number? Well, let's take a look. Let's give e to the power of negative 0.5, let's say negative 2, negative 1, equal to 1. So 3e equals to negative 0.5. Upon doing a calculation, I found that 3 is multiplied by 0.606, which is positive. Therefore, 3 times this answer will be 1.82, and it can't have a negative answer. So I will say that the answer, the positivity, depends upon e to the power of negative 0.5t. So it is never equivalent to 0 and negative numbers because of e to the power of negative 0.5t, as I've shown above. Therefore, I hope you all have a great day and good luck for your IGCSEs.